Hi to everyone. I am Dr VNSR Venkateswara Rao, working as an Associate Professor in the Department of Chemistry in Institute of Aeronautical Engineering, Hyderabad. So today I would like to give the topic on one of the important problems on electromotive force of a cell. So first of all, before starting the topic, we see what are the contents in today's section. So first we see introduction to EMF of a cell. After that we continue the model problems. Now let us see introduction to EMF of a cell. So first of all, the voltage or electrical potential across the terminals of a cell when no current is drawn from it. So that is nothing but a electric potential. And what is the electromotive force? The electromotive force is the sum of the electrical potential differences produced by a separation of charges, electrons or ions. That means that can be occur at each phase boundary or interface of the cell. And now we see what are the units for the EMF cell. EMF uses the SI unit, so that should be equal to volt. So that is called as a volt, and which is equal to the joule per coulomb. Joule per coulomb. That means there are two units, either volt or joule per coulomb. And what is the formula for EMF of a cell? That is nothing but E cell, E cathode and E anode. That means the potential at cell should be equal to the potential arised at cathode occurs by the reduction reaction, and the potential occurs at anode oxidation reaction. So always reduction reaction takes place at right side, and oxidation reaction takes place at left side of the cell as per the electrochemistry principles. Okay, now let us see the problems. Calculate EMF of a cell if the reduction potentials of the cell are minus 0.763 volts and 0.337 volts. That means as per the given data, out of the two potential, one is the negative potential and another one is the positive potential. So that means we understand that always the positive potential, that means positive potential occurs at right side, that is equal to cathode. So already we said that what is the reaction takes place at cathode? That means reduction reaction. So reduction means nothing but gain of the electrons, and negative potential occurs at left side, that is equal to anode. So always at anode what happens? Oxidation reaction takes place. Oxidation means loss of the electrons takes place. That means at cathode what happens? Gain of electrons. And always at cathode what happens? Always at anode what happens? Loss of electrons. Okay, so this is the electrode reaction takes place at anode and cathode, and respective potential takes place at anode and cathode. Always at anode, present at left side, undergoes oxidation reaction, that means loss of the electrons, and finally it gets the negative potential. And always at cathode, it present in right side and undergoes reduction reaction, that means gain of the electrons, and finally it gets the positive potential. Now as per the given formula, EMF of a cell is equal to the potential at cathode minus the potential at anode. So that means EMF of a cell should be equal to the potential at cathode minus the potential at anode. So what is the potential at cathode? Nothing but 0.337. Already we discussed about positive potential belongs to cathode minus, and what is the potential at anode? 0.763 volts. That means negative potential at anode. So that means minus of 0.763. Finally 0.337 minus of minus plus 0.763. We get 1.1 volts. 1.1 volts. So this is the solution for the given problem, and the EMF of the cell should be equal to 1.1 volts. Now let us see the second problem. Calculate the EMF of a cell if the reduction potentials of the cell are 0.365 volts and minus 0.734 volts. Again, they give the both positive potential and negative potential. So that means the positive potential at cathode and negative potential at yeah. Already we discussed about always at anode oxidation takes place, loss of the electrons, that's why it gets the negative potential, and at cathode always reduction takes place because of the gain of the electrons, it gets the positive potential. And the formula is E cell is equal to the potential at cathode and the potential at anode. So that means we get positive potential should be equal to 0.365 volts minus, and the potential at anode minus 0.734 volts. That means 0.365 minus of minus plus 0.734 volts. Okay, finally we got 1.099 volts. Okay, so this is the solution for the given problem. They ask the EMF of a cell that should be equal to 1.099 volts. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.